Let's talk a little bit about the angle-side angle postulate and vertical angle theorem, concepts that come up in lesson 10. A quick refresher on angle-side angle and vertical angle theorem. This short video, again, is meant to be supplementary, not instructional. So if you're watching this and this is the first you've heard of the angle-side angle postulate or vertical angle theorem, I encourage you to pause this, go read about it in your lesson or watch my asynchronous video on those topics where I go into it in more detail and come back to this. So this video is for those of you who are already familiar with it, but I want to address some common mistakes I've noticed with students when dealing with and specifically identifying when angle-side angle is being applied. So a quick refresher, let's say I have two triangles. Here's one and here's the other. And I want to show that they're congruent. One approach to this is the angle-side angle postulate, which tells me that if I have two sets of corresponding angles, remember corresponding angles are angles in two different polygons that are in the same relative position. I've got two sets of corresponding angles that are congruent to one another. You can see I'm putting my congruent marks. So this angle is congruent to this one. That one is congruent to that one. Not only these angles, but their included sides are congruent. So that side as well, put 3 marks through that. If you can establish this, then you can claim that the two triangles are congruent to one another. So pay particular attention. It's two angles. It's an angle, a side, and an angle. And the order of this acronym is kind of giving you a clue that you will see these things in order. You see the angle, you see the side, and then you see the angle again. And that's why the acronym is ordered that way. Again, it needs to be the included side. So, and what that means really, if I'm looking at this angle and that angle, the included side is the side formed between the vertices of those angles. So the vertice of this angle is this point right here. The vertice of the other angle is this point right here. So you can see the line segment between them would be the included side. So that's angle-side angle, two sets of corresponding angles and a congruent side, the included side. Means that I can prove that the triangles are congruent. Now, the vertical angle theorem, really briefly, tells me that if I've got two intersecting lines, remember lines meaning I've got straight lines, if I've got a set of intersecting lines, then non-adjacent angles are congruent. In other words, that means opposite angles. Okay, so adjacent means next to each other. So non-adjacent means any two angles that are not next to each other. Another way of saying that is simply to say opposite, right? So that means these two angles are congruent to one another. This angle is also congruent to that one. Okay, so each of this formed 4 angles. Each set of my 2 angles that are opposite of one another are congruent. Okay, so that information is going to be useful when we look at this example, which again demonstrates a mistake that I've seen lately that I want to address. So let's say I'm told that C is the midpoint of AD. And I'm told that angle BAC, this angle, is congruent to angle EDC, this angle here. So I know that these two are congruent. How can I show that my two triangles, triangle BAC and triangle EDC, are congruent? So for the sake of what we're doing today, I don't really mean this as a proof. I just mean what possible road could we take to accomplish this? Okay. So from the definition of midpoint, if C is the midpoint of AD, then AC, this line segment, must be congruent to CD, this line segment. Okay. So notice I've already established I've got a pair of corresponding congruent angles and a pair of congruent line segments. I've got an angle and a side. I also know, because AD and BE are vertical angles, I also know that these two angles are congruent by the definition, or really by the vertical angle theorem, right? So notice I've got an angle, a side, and an angle. I've got an angle, their included side, most importantly, and an angle. So if I wanted to know how I could show this, I would use angle, side, angle. Okay. Now the mistake that I see is to think that because C is the midpoint of AD, that it's also the midpoint of EB. Let me show you what I mean here. So this is not correct. So we see, okay, well, C is the midpoint. I know AC is congruent to CD. So we make this assumption about CE and BC. I cannot assume that those are of equal measure or that they are congruent, okay, unless I'm told C is a midpoint of that line segment, which I was not told. So the temptation then becomes to use side angle side, but here I don't have enough information to use side angle side theorem, and hopefully you can see that. I do know that information about these angles, but I don't know anything about this side, so side angle side is not an appropriate approach here. So one other thing I would say is to be really careful just when you're working out these problems and when you go to click your answer. I think sometimes you could do all the work correctly. You could identify that this is angle side angle and just get confused when you're typing or clicking the answer. Okay, so what I recommend if you're looking at this diagram online, for example, draw it out in your notes, do exactly what I did. You can see I put all these scribbles over it to kind of help me organize it. I even wrote out the letters ASA as I found congruencies. Okay, that's going to help you make sure that you click on the right answer and get the credit that you deserve. So that's one thing I wanted to discuss. The other thing relates to right angles. So in the last picture, if you remember, in the last picture, we were told that first of all, the picture tells us just by the diagram itself that those two angles are right angles. And it also even said in our given here that angle BAC was congruent to EDC. Okay, so they gave us kind of extra information to make sure we knew that those angles were congruent. Not only did they tell us that they were both right angles, they actually told us in the prompt that they were congruent. So here's a similar scenario, right? It's the same diagram. Once again, I know that C is the midpoint of AD, so those line segments are congruent. Imagine you were given this picture and then asked the same question: how can you show that those two triangles are congruent? Once again, I've got my congruent sides, right? And I still know from the vertical angle theorem that those two angles are congruent, right? But I don't know anything about these angles. And my point is that even if angles look like right angles, you can't assume it. It has to be told to you in some way, whether they just tell you flat out that those angles are congruent or that they are right angles and you could apply the right angle theorem. Again, unless you know that they are both right angles, you can't assume it. In taking this a step further, even if the diagram had told me that angle D was a right angle but still didn't mark anything about angle A, I would still be stuck. Okay, you have to know it about both angles. That relationship has to be established. So in this case, if I was told this, I can't say anything about those angles. I don't know anything about these sides. Knowing stuff about these other sides would actually be useless, right? This would be a case of not enough info. Okay? And don't be afraid to pick that answer, okay? Sometimes it happens. So, again, you can't assume right angles unless they are explicitly told to you, and it must be both of them, not just one, okay? So, when identifying the angle side angle theorem, just be extra careful. Don't make assumptions about right angles, and write it out as you go so that you don't mistakenly mark side angle side or some other incorrect postulate or theorem.